Music is, as always, provided by the ever-amazing Zircon. And 3, 2, 1, we are on. Let's see this problem statement, and it's a bad gateway. Okay, there we go. Okay. We need stars, it's the usual thing. Okay. Frequency drift. Sequence of changes in frequency, puzzle input. So it's a bunch of incremental steps in one direction or another. Okay, so I just have to sum all the numbers in sequence as far as I can tell. That's a lot of numbers. Let's get them tossed into our input file. Done. Okay, let's... Oops. Pow. We now have an input. Now we need to actually parse these fellows out. Let's see, def parsed input. Whoops. We're going to take input. Let's see what we're going to do to it. I'll need string, won't I? If I can type today. As tr, okay, that's my standard import here. Split, I think it's called. On new line. Okay, let's just vet here what we get. Let's save. Doesn't like that. It needs to be a pattern. Okay, let's try that again. Make this a regex. Save. Doesn't like that either. Ah, I see why. Okay. Okay, I think we got it. So now we have a split. Let's see. I think we can say with safety that we can then map. Let's go do this. Map. Integer / parse int. I think that'll do it. Well, that's interesting. Let's just make this an FN really quick, just to make sure that I'm not doing anything dumb there. That seems to have worked, so let's just validate that. Let's evaluate our last form, which is here. Okay, it seems like it parsed it okay. Let's go ahead and reduce plus parsed input. I think that should do it. 470. I'm entering that code in. Oh, and you've been staring at a blank screen this whole time because I'm an idiot. Take some practice to learn to stream. Okay, now you can see what I've actually been doing. This is now a ruined stream, but oh well. Yeah, I'm just realizing that as I go. 470. Okay, part 2. Bring the problem back up again. This time I'll remember to turn it off. And notice that it's repeating the same frequency change list over and over. To calibrate the device, you need to find the first frequency it reaches twice. So this is a standard reductions type of problem then. Let's kill the problem. We've got Emacs here. Let's go ahead. Instead of doing reduce, we're going to do Oh, let's see, what's it called? Reductions, I believe, plus parsed input. And so if I run that real quick, let's just see what this looks like. It'll actually give the incremental steps one by one of each item, if that makes any sense. And you know what? We could do this more interestingly. Set function of all the values we've seen so far and the new value. If seen, let's see, not quite what I'm looking for. If seen values, new value, we'll reduce new value, aka we'll just cut short, we'll say this value's been seen, we're done. Otherwise, we're going to continue with a conj seen values, new value. So we'll add, if we've seen the value before, we'll return it, otherwise we'll add it to our current set. Give it a blank set to start with, and hand it our parsed input. Oops. Let's close our function here. Let me validate something. Okay, so that should work. If I've seen this value before, reduce it to a new value. Otherwise, oh, that should not be there. Wow. The value I've most recently seen is 2. So that's the one I should see twice first. Let's validate that. Nope, not right. Incorrecto. Ah, you know what? Is the starting 0... Yeah, the starting frequency is 0, so I might be seeing 0 first, actually. Nope, still seeing 2. So this isn't working as intended. Ah, I see why. I'm just gathering all the values. I'm not adding them or anything. Oh boy. Yeah, I screwed that up. Oh, actually, I see why. I don't want the parsed input. So right now I'm just calculating each differential, each plus or minus value. I don't want to do that. I want to collect all the added values. So the frequency I'm at after adding each individual step. It's hard to explain. That I can get by reductions. Still not working. Okay, let's start by making sure this is a little more readable, so that I'm making sure I'm not missing anything dumb. So if I see the new value, the list of scene values, I grab that. Let me vet the signature of Conj, because this has been a very long time since I last used Clojure, and I might have easily swapped my arguments around. No, yeah, Conj takes the collection first, and the value to add to the collection second. Just to vet my understanding of what this is doing, let's make that a reduction as well. Let's see what we're getting spit out. Oh, it's huge. Take 3? So that looks right. That looks like what we would expect to see. Or it's just incrementing and adding one thing at a time. Let's kill the take. So this is giving back the whole set, which implies that it's not seeing the same value twice. Ah, okay. There's a trick here. It's not guaranteed that you'll find it the first time. You have to actually loop that set of inputs over and over and over. So it's not just the input once, it's the input many times. AKA, I need to cycle the parsed input. There we go. That's the wrinkle in the problem. Gotta read the whole thing, folks, every time. 790 is the answer I'm getting. Let's try that. Okay. Whenever you're getting stuck and you feel like you're not seeing what the issue is, read the problem again. That's almost always the issue. So, in conclusion, we take our input, split it by new line, so we have our list of numbers. We make sure that they're actually translated as numbers. Java handles the pluses and minuses nicely, so no problem there. We go ahead and get the first answer by just using classic reduce, aka take each item, take the first two items, add them together. Take that result, add the next number to that, etc. Reduce all the way down to one distilled value. That got us the first problem. The second one's a little trickier because we have to sit there and repeat that list of movements up and down over and over and over until we find a duplicate in that long list. So, first of all, we have to figure out how to get it to cycle over and over and over. Clojure gives us a fantastic tool for that. Just cycle that list. It'll repeat infinitely until you tell it to stop. Reductions is like reduce, where we said we took those two numbers over and over, add. Except instead of just giving us the final result, it gives us intermediate results. So it says, here's a list that says, here's the first number alone, the first two numbers, the first three numbers, etc. So it shows you the incremental steps along the way, and that ends up showing up a lot in a lot of these problems. So now we have a list of all the frequencies we stopped at along the way. And we go ahead and use reduce again and say, hey, keep a set of all the numbers we've seen, starting with 0. And every time we see a new number, we add it to the set. If we see the same number, then we've found our solution, and we use reduced to shortcut out of it. And that prevents us from going off on an infinite loop and adding numbers forever and ever and ever and ever and ever. We say, hey, well, we're done processing. We're going to stop here. Yeah. So in all, pretty good. This is actually a good one for Clojure. Takes advantage of some of its nicer features. Cycle's always so nice to have around, simpler than a typical loop. And keeps things simple. I'll go ahead and tidy this up, commit this out to the repo, and maybe see you for day 2. It is just an experiment anyway. You spent the first chunk of it just staring at a blank screen, so I don't blame you if you don't come back. Anyhow, take care, have fun with your own version of Out of Code, and keep learning languages, whatever you do.